A warm welcome to all of you in this module on ceramics. As you are well aware that we have been discussing our course on processing of non-metals, which has been divided into 7 different modules. We have completed 2 modules in which we have seen the different aspects of materials, we have seen the manufacturing aspects of engineering materials, and then in the second module we have seen the glasses. As the title of the course is processing of non-metals, so our focus is on 2 important aspects, that is the non-metals and their processing techniques. And in this particular course, that is processing of non-metals, we would be covering different types of non-metals, such as we are today going to start our discussion on ceramics, and at a later stage in module number 6 we would be covering ceramic matrix composites, which would be an advanced stage of basic ceramics or monolithic ceramics, where the material has been modified in order to take advantage of the properties of the ceramics and in order to overcome the limitations of the ceramics. So, that is at a later stage, that is in module number 6, and we are going to cover the polymers as well as the polymer matrix composites. So, now we are at a stage where we are going to start module number 3. In module number 4 our focus would be on polymers, in module number 5 our focus would be on polymer matrix composites, and in module number 6 again we will discuss the ceramic matrix composites, and finally in module number 7 our focus would be on the secondary processing aspects of these composite materials or advanced materials or non-metallic materials. So, today we are going to start a new module, that is ceramics. In ceramics our focus would primarily be to understand the basic aspects of the ceramics, that what are ceramics, how the ceramics can be classified, what are the various criteria on the basis of which ceramics can be classified, what are the distinct features of ceramics, what type of bonding exists in ceramics, what are the different types of ceramic raw materials, and finally we are going to see what are the applications of the ceramics. So, this is something related to the materials aspects of ceramics, that is the material science aspect of ceramics. Then we would shift our focus from the materials aspects of ceramic towards the processing aspects of ceramics, in which we would be seeing different processes which are used for processing of ceramics, like powder processing technique is there, slip casting is there are a number of techniques which are used for processing of ceramics. So, we will see one by one all the techniques which are used for processing of ceramics. But in the first 2 lectures, that is lecture number 1 and lecture number 2, our focus is primarily to understand the basic aspects of ceramics. So, we would be covering these fundamental aspects in 2 lectures, that is ceramics 1 and ceramics 2. So, today we are going to start our discussion in our module 3, that is ceramics, and we are going to start the discussion with the basic aspects of ceramics. So, with this introduction, let us start our discussion on the basic aspects of ceramics. Now, this is the introduction to the word ceramics. The word ceramic is derived from the Greek word keramos, which means potter's clay, and keramikos, which means clay products. So, basically there are 2 important points that are coming in this particular word, that is ceramics, that is potter's clay and clay products. So, basically the traditional use of ceramics started with the use of clay and converting this raw material, that is clay, into some tangible products like pottery and some other products made up of clay. So, basically the word ceramic, it is very clearly mentioned, has been derived from a Greek word which means potter's clay. So, basically the concept or the science and engineering of ceramics started with the potter's clay and the clay products. So, basically ceramics deals with the name of the process also as well as the product also. So, product is also a ceramic and the ceramic making is also a process. So, basically first important point is to understand the origin, from where did this particular branch of science and engineering started, or this important aspect of material science started, that is from potter's clay, where when the raw material clay was converted into the final usable tangible product. Then from the historical point of view, till 1950s, the most important types of ceramics were the traditional clays made into pottery, bricks, tiles, etc. So the application aspects are also given and the raw material aspect is also given. If you have a look, the raw material are the traditional clay. So clay is a material and the product is the pottery, different types of pottery items, bricks, tiles, etc. So traditionally the clays were classified into the ceramics category, but later on different types of ceramics have been invented that we would be seeing in the applications of ceramics, like bioceramics, ceramics for electronics industry, then there are ceramics for space shuttle applications. So these days we have different sophisticated advanced ceramics available which are used for specific design requirements, but traditionally the ceramics that were used in engineering applications or in household applications were made from traditional clays. Next point, ceramic artifacts, that is the products made by ceramics, play an important role in historical understanding of the technology and culture of the people who lived many years ago. If you remember, during the excavation many times pottery shreds are found out, some ceramic products are found out, and then from the kind of, we can say, the artwork done on those ceramic products, the culture is estimated, that what was the culture or what type of people used to live and what was the cultural, we can say, heritage related to that particular era. So important point to note here is that this is an important type of a material which not only has engineering relevance but also has historical relevance, and it is, we can say, a household item which dictate or which helps us to understand the culture as well as the historical developments of a particular civilization or of a particular time domain. So basically this particular slide highlights the important aspects of ceramics, that somebody who is listening to this word ceramic for the very first time should be able to understand that what is a ceramic, from where it has got its origin, and what are the traditional applications of this particular material and what is its relevance in society. So these particular points give us an idea that it is an important material which is in use for a long time, and particularly now has gained substantial application spectrum in different engineering applications that we are going to study in our subsequent slides. So basically the focus is on the word ceramic, and we are going to understand the basic fundamental aspects of ceramics, and then we will see that what are the latest applications of these materials. A ceramic material is an inorganic non-metallic material and is often crystalline. So this important point highlights three important aspects of ceramics, that is, a ceramic is inorganic, that is point number 1, it is non-metallic, is point number 2, and is often crystalline. In our previous module, if you remember, we have discussed lectures on glasses and we have seen that glasses are usually amorphous. So ceramic material is a crystalline material, and we have also seen the distinction between the crystalline material and the amorphous material. So ceramic material is inorganic, it is non-metallic, and it is often crystalline. So second important point is very important, that is non-metallic, because now we are discussing the course on processing of non-metals. So ceramic is one of the important non-metals, and we should know the tools and techniques for high quality cost effective processing of ceramic materials. So basically, again I am highlighting and revising because this is a very simple definition of a ceramic material, and anybody who is attending to this particular discussion should be able to remember that what actually a ceramic is. A ceramic is an inorganic material, it is a non-metallic material, moreover most of the ceramics are mostly crystalline. Second, the traditional ceramics are clays. As we have already understood in the very first slide that the very basic origin of the word ceramic is from potter's clay. So basically the traditional ceramics are clays. The earliest application was in pottery, that we have also seen in the previous slide. Most recently different types of ceramics are used, such as alumina, silicon carbide. So these are just two examples of the latest use of ceramic materials. There are different types of ceramics. Ceramics is a very huge family, and there are large number of materials that fall under this category and are being used in different engineering applications. So just to make the things simple and easily understandable, I have taken just two very simple examples of the latest materials which fall under the category of ceramics. So most recently different types of ceramics are being used, that is alumina and silicon carbide. So the latest advancements are, now these are two examples of the ceramics, then the latest advancements are in the fields of bioceramics, that is sometimes biomedical implants are being made up of ceramic materials, and dental implants as well as synthetic bones. So basically now we are trying to understand that what basically a ceramic is, what is the historical perspective of the ceramic material, and we are trying to understand the application point of view of the ceramic material, that what are the latest applications, like in the last point we can see artificial bones or synthetic bones, dental implants as well as the bioceramics. So these are some of the applications of ceramics in today's scenario, and two examples of ceramic material, latest ceramics that we have seen, that is alumina and silicon carbide. We would be seeing a large number of, we can say, applications of the ceramic material in today's lecture and in the subsequent lectures. So by now if we revise what we have covered, we have just seen that what basically a ceramic is. It is an inorganic non-metallic material which are mostly crystalline. Then we have seen two important examples of a ceramic material, that is alumina and silicon carbide. Then we have seen some of the latest applications of the ceramic materials, like the biomedical implants, the dental implants or the synthetic bones. So now we will carry forward our discussion and have a comparative analysis of the ceramics with the other important engineering materials like metals and polymers. Basically the purpose of showing this particular slide is that we want to compare the ceramic with the metal. Basically our course focuses on processing of non-metals. So polymers and ceramics both are non-metals. So we have to compare the characteristics of these two particular materials in reference to the properties of the metals, because these properties only would dictate the processing techniques for these materials. So one by one we can try to understand the difference, that what are the good properties of ceramics which are not present in the metals, or what are the danger areas or limitations in ceramics where metals have got an edge. So first important property on your screen is density. So density, you can see ceramics have low density, metals have high density and polymers have lowest density. Now from the density point of view, if we take the application spectrum, that what type of applications are relevant to the density, then we can say the low weight applications are particularly relevant to the density of the material. So metals have high density, therefore the use of metals for lightweight applications is not usually feasible or is not advisable, whereas in case of ceramics the density is low, in case of polymers the density is lowest. Therefore for lightweight applications there are a large variety of materials which have been developed using ceramics and polymers and are being used for lightweight applications, specifically in aerospace industry, in marine industry, in sports goods and equipment. There are large number of applications where lightweight is the prime design criteria, and in those cases ceramics and polymers have an edge over the metal. So first important property that ceramics have an edge is the lightweight characteristics, that is the density of ceramics is less as compared to that of metals. Property number 2, that is hardness. Ceramics have high hardness, that is the highest hardness, metals have low hardness and polymers have the lowest hardness. So if we compare the metals with ceramics, the hardness of ceramics is much higher as compared to most of the metals. So the hardness is an important property where we are focusing the use of wear resistant materials. So when we want to have a wear resistance, we tend to increase the hardness. So hardness is good for ceramics, it is higher for ceramics, but for metals it is lower. So hardness also, if high hardness is required, ceramics have an edge. Ductility, which is another important property, is low for ceramics and it is high for metals. So plastic deformation or bending or any other process to give a shape to the metal, it is easier in case of metals, but in case of ceramics it is difficult because they do not have the property of ductility. So ceramics, the ductility is low, whereas in metals the ductility is high. Therefore the metals can be drawn into thin wires, metal can be plastically deformed, whereas ceramics cannot be drawn into thin wires. Even if possible, then very precise control over the processing parameters is required. So therefore the ductility of the ceramics is lower as compared to that of metals. The next property, as I have already highlighted along with point number 2, that is hardness, is wear resistance. So wear resistance in case of ceramics is high, whereas in case of metals is low. So we can say wherever we want to have an application of a particular material where wear resistance is an important design requirement, there we would advocate the use of ceramic materials as compared to the metals, because the wear resistance of ceramics is higher as compared to that of metals. Coming on to the corrosion resistance. So corrosion resistance is also higher for ceramics as compared to that for metals. Thermal conductivity is mostly low for ceramics in most of the cases, although there can be some ceramics which may have a temperature dependent conductivity and may go into the superconductivity range at an elevated temperature, but those are specific examples or exceptional cases. But in most of the ceramics we will see that the thermal conductivity would be low as compared to that of metals, and the electrical conductivity would also be low as compared to that for metals. So we have seen in this particular table the comparison between the ceramics and the metals. The other comparison between the metals and the polymers we will see when we will start discussing the module on polymers. But if we compare the two important class of materials, that is the metal and the ceramic, we can see that for lightweight application, for high temperature applications, for wear resistance, corrosion resistance applications where wear resistance and corrosion resistance is desired, we should certainly use the ceramic materials. But wherever we want high electrical conductivity or we want good thermal conductivity, in those cases we should go for metals as our alternative. So basically ceramics have got certain advantages and metals have got their own advantages, but apart from the advantages that the ceramics have, there are few limitations also, because ceramics have a major advantage of high temperature suitability. For high temperature application ceramics can be used. Then they have good corrosion resistance also. Therefore in some applications we may love to advocate the use of ceramics where high temperature is there, corrosion resistance is also there. So we may be initiated or we may be motivated to advocate the use of ceramics, but one of the important points to note is the brittle nature of the ceramics. So whenever we are going to advocate the use of ceramics for a particular engineering application, we should take into account the type of loads that are going to come on that particular component. So if impact load is going to come, then we should not advocate or we should not initiate the use of ceramic material for that particular application. So although ceramic materials have got a wide variety of properties like high hardness, we can say low density. So for lightweight applications, high hardness for wear resistance applications, corrosion resistance application. Yes, we may be tempted to promote the ceramic materials, but one of the major limitations is the brittle nature. So that particular aspect has to be addressed, and that we will try to address when we will study our module on ceramic matrix composites, where the ceramic matrix is reinforced with the reinforcing phase, and some of the properties of the ceramic which are lacking are improved with the help of the reinforcing phase. Although the advantageous properties of ceramics are taken care of, they are usually adopted into the ceramic matrix composite, but the limiting properties of ceramics are addressed by the reinforcing phase, and we get a good quality material which overcomes the limitations of the monolithic ceramics. So the important point in this particular slide is to have a comparative analysis of the metals and the ceramics, and we should be able to understand that what is the application spectrum. As an engineer, we should know that whenever we are designing a product, we have to specify the material which would be used to fabricate or process that final product. So basically, before advocating the use of a particular material, we should know that what are the strengths of that material and what are the weaknesses of that material. And this particular slide gives us an overview of the comparison between the metals and the ceramics, and we have been able to understand that what are the properties which are good for ceramics as compared to metals, and what are the important challenges for ceramics which have to be overcome with the blending of other phases or other materials with the ceramic materials. Now let us see what are the important applications. We can have pottery products, sanitary ware, floor and roof tiles, that is one spectrum of applications. Then crucibles, kiln linings, other refractories. Refractory means high temperature applications. Then high end applications are there. So we started from the very basic application or household applications like pottery products or sanitary ware, which is there in every household, floor and roof tiles also. So we are starting from the consumer goods. Then slightly high end applications like the crucibles, kiln linings and other refractories, that is high temperature applications. Then high end applications such as ceramic matrix composites. So ceramic matrix composites we are going to cover in our module number 6. We will see that what are the various types of toughening mechanisms. We will try to understand that what are the various types of manufacturing processes or processing techniques which are used for ceramic matrix composites. So this is another class of material which is finding substantial application in various engineering requirements. Then the tiles in space shuttle, this is also a high end application. Bulletproof jackets, disc brakes, ball bearing applications, bioceramics. So these are some of the latest applications of the ceramic materials. So starting from the very basic application, household application, we can see the ceramics have now graduated into a very important class of engineering material and is finding diverse applications in the fields ranging from aerospace to bioceramics. Now till now what we have discussed, let's just have a brief overview of what we have tried to understand till now. We have tried to understand the brief origin of the ceramic materials, the traditional clays which have been used for a long time, that initially the ceramic materials were used as clays. Then we have tried to understand the basic concept of the ceramics. We have tried to compare the ceramics with the metals, and then we have seen what are the various applications of ceramic materials. So having this introduction, that what do we mean by a ceramic, how the ceramic materials compare with the metallic materials, and finally the applications where we can see the ceramics around us, because all of us can see the ceramic materials all around us. We can see the roof tiles, we can see certain decorative pottery items which are usually kept in the houses. So basically we can, till now we can just visualize that what are the various applications of ceramic materials. Now let us see how the ceramic material can be classified. So the classification can be based on two important criteria. So the ceramics can be classified in a large number of ways. We can choose different types of criteria for classifying the ceramic materials, but broadly there are two important criteria which have been widely accepted as the classifying criteria. So mostly the ceramics can be classified on the following basis. So two important classifying criteria are classification based on the composition of the ceramic material and the classification based on the applications of the ceramic material. That is why in the previous slide we have seen, starting from the very basic application or household application, the applications of ceramics may range to bioceramics and the bulletproof armor. So on the basis of applications also the ceramics can be classified, as well as the ceramics can be classified on the basis of the composition of the base material. So the in this particular ceramic, we will see in our subsequent lectures that the ceramic is made up of 2 or 3 different elements, and therefore the structure of the ceramics is also very complex as compared to the metallic materials, but that we will come to at a later stage. But let us first see the broad classification of the ceramic materials. Now, classification of ceramic materials on the basis of composition, we can broadly classify them into 4 categories. Silicate ceramics, which is one of the most commonly used ceramic material. Oxide ceramics like alumina, one example I have given. We will just see some other examples of the oxide ceramics also in the subsequent slides. Non-oxide ceramics and the glass ceramics. So glass ceramics is also a very important class of ceramic materials which is finding a wide variety of application in today's engineering world. So basically, on the basis of composition, we can classify the ceramics into 4 categories. So all those 4 categories have been highlighted on your screen, and one by one we will try to see that which particular type of ceramic falls under which category. So again, we can see that in this particular diagram we have been able to classify the ceramics into 4 broad categories based on the composition. Now one by one we will try to understand that silicate ceramics, oxide ceramics, non-oxide ceramics and glass ceramics. The main types of silicate ceramics are, these are the most commonly used type of ceramic materials. They are clay based ceramics, talc based technical ceramics, or special groups such as zircon and mullite based fine ceramics. But we can try to understand here that one of the broad categories based on the composition of the material is the silicate ceramic. So major type of this particular ceramic products are made by the silicate ceramics, and they can further be subdivided into clay based ceramics, talc based technical ceramics, as well as special groups or fine ceramics. So basically, first important category on the basis of the composition is the silicate ceramics. We should try to remember that on the basis of composition there are 4 types of categories of ceramics, or 4 types of, we can say, subdivisions of the ceramic materials on the basis of composition. That is, first one is the silicate ceramics, which is most widely used. Second is the oxide ceramic, non-oxide ceramics and the glass ceramics. So the first one is the silicate ceramics, different types is already mentioned on your screen. The next is the oxide ceramics. So coming on to the oxide ceramics, the oxide ceramics basically include alumina, zirconia, and there are other types of oxide ceramics also. Now what are the important properties of the oxide ceramics? We can have high melting points and a wide range of, or wide variety of electrical properties. Now there are different examples like glazes and protective coatings. They seal porosity, improve water or chemical resistance, and enhance joining to metals or other materials. So we can say the application areas of oxide ceramics are also given. So we have seen that 2 examples of oxide ceramics, we have seen 2 specific properties of oxide ceramics, and we have seen the application that they can be used for glazes and protective coatings, for sealing the porosity, as we have seen in, we can say, important application, because ceramics are porous in nature. So sometimes we want to reduce or seal the porosity, so there the oxide ceramics can be used. Improve water or chemical resistance, that is also very important, as we know that corrosion resistance and chemical resistance of oxide ceramics is good. And they enhance the joining to the metals or other materials. So, oxide ceramics is one category on the basis of composition which is falling under the ceramics category. Then non-oxide ceramics, there are large number of, we can say, materials related problems and difficulties and limitations. As we know that whatever properties we desire from a particular material, all those properties we cannot achieve with one specific materials. For example, for a very high temperature application, at that particular application we require high strength of the material also, the mechanical properties should not deteriorate at an elevated temperature. So, this is just one example of a very specific requirement. So, there are very diverse requirements from the engineering materials in today's world. So, basically in past 3 to 4 decades, many severe material problems and difficulties are there. So, problems such as corrosion, erosion, wear, temperature, electrical insulation, etc. So, these are some of the problems that exist. So, these can be overcome by the correct selection of range of materials categorized as oxide and non-oxide ceramics. So, non-oxide ceramics, this is just giving you an highlight that in which particular application spectrum the non-oxide ceramics can be used. But what are the exactly non-oxide ceramics, that also we should try to understand. In oxide ceramics, we have seen the two important examples are alumina and zirconia. So, in case of non-oxide ceramics, we can have carbides, we can have nitrides. So, carbides, nitrides fall under the category of non-oxide ceramics, and within carbides we can have silicon carbide, we can have titanium carbide, we can have tungsten carbide. So, we can have different types of carbides, we can have different types of nitrides, and these will fall under non-oxide ceramics. So, carbides and nitrides will fall under non-oxide ceramics, and alumina, zirconia will fall under the oxide ceramics. So, till now on the basis of the composition of the basic material, we can classify the ceramics into 4 categories, that is, first one is the silicates, second is the oxide ceramics, and the third one is the non-oxide ceramics, and the fourth category is the glass ceramics. But before going to the glass ceramics, let us see the examples of non-oxide ceramics. I have already told non-oxide ceramics basically are carbides and nitrides, and they have got their own specific set of applications. Now, coming on to the glass ceramics, a material processed through the controlled crystallization of the base glass. So, we have seen in our previous module that was on glass that what is the difference between amorphous and crystalline material. So, glass is basically a amorphous material, but a glass ceramic is a material which is processed through the controlled crystallization of the glass. So, we will have certain degree of crystallinity, and that would add a specific dimension to the material and would make it applicable in certain application areas. So, amorphous phase and more than one crystalline phases and are produced by a controlled crystallization procedure. So, the glass ceramic will exist in amorphous phase and more than one crystalline phases, and how it will be processed by the controlled crystallization. We know that we have to undertake this much amount of crystallization. So, 30 to 90% crystallinity and yield an array of material. So, we will get different types of materials. So, basically glass ceramics are, we will process the glass and later on add certain degree of crystalline nature into that base glass, and we will get a glass ceramic. Why do we need to do this? Let us try to understand this. Glass ceramics hold the processing advantage of glass and has a special characteristics of ceramics. So, basically a question can be asked that what is the need when we have a glass as an engineering material and ceramics is another category of engineering materials, what is the need to blend these two characteristics together or to blend these two materials together. So, first important point is on your screen you can see the glass ceramics, they hold the processing advantage of glass because it is easier to process glass as compared to ceramics and has a special characteristics of the ceramics. So, ceramics have got certain specific properties that we have already understood in one of the previous slides where we have compared the ceramics with the metals. So, we want to take advantage of those properties and take advantage of the processing ease of the glass, and then we combine these two important characteristics together, the processing characteristics of glass and the other properties of ceramic, and we get a glass ceramic. So, that is one of the important points why we want to blend the two together. Properties of material zero porosity, maybe the properties of the material, that glass ceramics, what type of properties they possess. Zero porosity, porosity is very less. High strength, so strength is improved. Toughness is good. Translucency or opacity, we can have whatever we want or we can design accordingly, and superconductivity. So, basically glass ceramics have got certain special characteristics. Now, what are those special characteristics? That is mentioned on your screen. Again we want to revise: the porosity is less, strength is good, toughness is good, we can have a range from translucency to opacity, and the superconductivity. So, we can see that although the ceramics are poor conductors of electricity, but glass ceramics can be made superconductive at specific operating conditions. So, basically when we blend the two things together, that this particular concept we are also going to see in case of polymer matrix composite and ceramic matrix composites in later modules of this particular course. But here also we have combined the characteristics of two things together, or two materials together, glasses and ceramics, and we have been able to make a resultant material which is giving us certain special characteristics as mentioned on your screen. You can see porosity, low porosity, high strength, toughness and superconductivity. Properties can be altered by controlling composition and by controlled heat treatment of the base glass. So, these are not the only properties, or this is not the only characteristics that these materials possess. There are other types of properties which can be achieved with the controlled heat treatment or by controlling the composition of the material that we are forming. So, just let us take a revision of what we have seen in the classification of the ceramics. We have seen that on the basis of composition we can classify the ceramics into four broad categories. That the first one is the silicate, second one is the oxide ceramics, third one are the non-oxide ceramics, and the fourth one is the special category of glass ceramics. Now, second characterization or second classification is on the basis of applications. So, we have seen that although there are number of ways to classify the ceramic materials, but we are basically focusing on two important criteria, that is on the basis of composition of the material and on the basis of the applications of the materials. So, on the basis of composition we have already seen there are four subcategories. In case of applications, now we can see we can have glasses, high performance advanced ceramics such as bioceramics or for ceramic tiles for space shuttles, traditional vitreous ceramics, that is the most commonly used clays, cement and concrete, and finally the naturally occurring ceramics such as our bones. Now, glasses are based on silicate along with other additives to shrink the melting point and to impart special characteristic property. This just gives a revision of what we have already covered in our module number 2. Mainly used in manufacturing of the following products like containers, household equipment and optical glasses. As we have seen, there are number of other applications of glasses. So, for the detailed discussion on glasses you can refer to the discussions on module 2 or discussions held in module 2, in which we have seen the different types of glasses. High performance advanced ceramics, that is the next category on the basis of the application. They are usually special ceramics having outstanding measures in terms of toughness, wear resistance and electrical properties. Their applicative demand has rose to a large extent in the last decade, and they find their need in cutting tools, like sometimes we used the carbide tools for machining purposes. So, we can have different types of hard tools which can be used for machining, grinding, bearing, ball bearing applications also are the latest applications of ceramics. They are used for sensors also, lasers, superconductors. So, we can see that high performance applications for ceramics also are there, and the ceramics can be classified into a category where they are used for high performance applications. Some of the applications which are not mentioned here are in case of bioceramics or in space shuttles or our body armor, bulletproof body armor. So, we can see high performance advanced ceramics is one category, although few examples are listed on your screen, there are other examples as well. Traditional vitreous ceramics, you can see all the clay based products within the ceramics comes under this category. So, clay based products usually are traditional ceramics. Applications are easily noticeable in porcelain, sanitary ware, tiles, bricks, refractories, which we have already covered in this lecture. Only in the very beginning we have seen that what are the typical applications of ceramic materials. Now, we are classifying the ceramic material into different categories on the basis of applications. Then cement and concrete is another, we can say, subcategory of the ceramics based on the application, that is these are multi-phase in nature, they exist in more than one phase. So, multi-phase means they exist in more than one phase. Concrete and cement is well known commodity, I think all engineers know about this. Natural ceramics, these includes rocks, minerals, ores that are extracted from the earth and are produced by laws of nature. They are also include the bones. So, basically there are natural ceramics also which can be used for certain applications. There are, we can say, cement and concrete category for the ceramics on the basis of the application. Then there are high performance ceramics, then there are traditional clays etc., then glasses, glass ceramics. So, on the basis of the application also we have got a wide variety of ceramic materials. So, whatever we have discussed, let us now try to highlight or try to summarize with the help of this diagram. Classification of ceramic materials. Classification based on composition, we can have silicate ceramics, oxide ceramics, non-oxide ceramics and glass ceramics. We have seen the examples of all four types of these. Classification based on applications, we can have glasses, high performance advanced ceramics, traditional vitreous ceramics, cement and concrete and natural ceramics, and the examples we have seen in each and every case. So, with this we come to the end of lecture number 1 in our module 3, that is ceramics. In our subsequent lectures, our focus would be to further investigate or further study the basic aspects of ceramic, to understand what is the type of bonding that exists in ceramics and how that bonding affects the properties, and finally see what are the mechanical properties of the different types of ceramic materials, and then we will shift our attention to the major focus of this particular course, that is the processing of non-metal. So, then our subsequent lectures would be focusing on the processing aspects of ceramics. In our next lecture, our focus would be on the basic aspects of ceramics. Thank you.